everyone. I want to show you how we analyze the data of the measurements for the box and block test. Now, this is a functional test that can measure improvement in the hand dexterity and fine motor functioning, which is a common issue with adolescents with CP. But using this test, the individual will face a rectangular box divided into 2 square compartments and see how many out of the 150 wooden blocks the individual can place from one compartment to the other. So let me just go ahead and share my screen here where we have our data. Okay, so as you can see here, we have an example of 4 participants, and out of the 150 blocks, participant 1 at pre-test got 20, post-test 24, participant 2, 17 at pre-test, 20 at post-test, participant 3, 27 at pre-test, 31 at post-test, and participant 4, 13 at pre-test, and 19 at post-test. So after gathering this information, we decided we're going to run some descriptive statistics, a t-test, and a correlation as we decided on pre and post scores for one particular program. This will give us the information we need to determine if the intervention was statistically significant. So first, we'll make sure that we're have the data tab right here, and then we'll go to data analysis. So when this comes up, you'll see you can scroll down, and the t-test paired to sample for means would be the one you want for this. And then, so everything's blank here. So for the variable 1 range, you'll highlight the pre-test scores, including the label. And then for variable 2, you'll highlight the post-test scores, including the label. The hypothesized mean difference will should be 0. You'll click on labels. Alpha should stay at 0.05. And then the output range, you'll click this, and this is just to determine where your data will be located on the sheet here. So pick wherever you want, and then click OK. So as you can see here, this gives us some information. I'll stretch this out a bit so you can see everything. So we have our mean, observations, everything like that. So to find out if it's significant, you want the two-tail p-value, which is right here, and then this is 0.06, showing that it is statistically significant. So now I want to find the standard deviation. So to do that, we have to run descriptive statistics. So back to data analysis, and then descriptive statistics. Okay, so once you're in here for your input range, again, you'll highlight the pretest with the labels. Select column, you want to make sure the labels is checked again. And then down here, you want output range checked again. And then you also want these last 4 boxes checked. And then once again, for the output range, just click wherever you want this information to be displayed, and then click OK. And then you have your information for the pretest. And then we'll just go ahead and do that again for the post-test. So data analysis, descriptive statistics, OK. We'll get this out of here, highlight this, the post-test, you're still on columns. This is all checked up. You just want to make sure you change the output range. So we'll go right next to it here. And there's the post-test. And let me just spread this out a little more so it's easier to see. Okay, so now that we can see our standard deviation, which is right here. We want to write out what these finding means. So to do so, let me come down here. And what we would write is a paired sample t-test was conducted to compare B and B, which is blocks and blocks, pre-test and post, I don't want that to get too far over, test scores. There was a significant difference in scores from pre-test, and here we want to include the mean, which the mean for the pre-test was 19.25, and then the standard deviation for the pre-test as you can see, was 5.9. We'll round it up, so 5.91. Okay, and post-test mean equals 23.5, and the standard deviation equals 5.4, and we'll round it up, 5.45. And then the T, 6 degrees of freedom, equals, as you can see right here, negative 6.75. Now, the number after T is the degrees of freedom, which is the amount of data under the pretest, which is 4, plus the amount under post-test, which is also 4, added together getting 8, subtracting 2, and then getting 6. And then you want your p-value, which p equals 0.006. So like I said, because it's lower than our p-value of 0.05, our alpha value, it is statistically significant. So next we want to find the correlation. For our presentation, we decided to test the correlation of the number of sessions attended, which I put down here, and the outcome scores. So once again, so this, you just bring down the post-test scores. And then the total numbers of sessions attended, the most could be 24. So participant 1, 23, 2, 23, 3, 24, and participant 4 at 22. And then this is their post-test scores. So once again, back to data analysis. And then for this, we will go into correlations. Click OK. And then for the input range, we actually want both columns highlighted for this. And then want to make sure that it still says columns. We're going to check label again. And then for the output area, let me just put it down here so the information up top isn't mixed with it. Range. Okay. Okay. So as we can see there, this is a positive number right here, so it is a positive correlation, but that doesn't necessarily mean that it is significant. So to do so, we have to run a regression analysis. So once again, we'll go to data and then data analysis, and then we'll go to regression. Click OK. And then for the Y range, you actually want to start with the outcome value, okay? And then for the X range, we want the number of sessions here. And then once again, we will keep the labels. We want our confidence interval checked and to keep that at 95. And then we will choose the output area. Okay, I'll put it right over here and then click OK. So this gives you a lot of information, and let me just make sure you can see everything here. So to find the significance, we're looking under the ANOVA regression significant right here. As you can see, this p-value is not significant as it is over 0.05. This is 0.101 when you round up. So to write what these findings mean, we will say there is not a significant relationship between the number of sessions attended and the box and blocks post-test score. Regression 6, which again is the degrees of freedom, equals up here, so rounded up, it's about 0.90, and which is the correlation number, and P equals 0.101. So that is how we did our statistical analysis and what we came up with. So as you can see, our intervention at pre and post test, those scores were significant, but the correlation between the number of sessions attended and the outcome scores were not significant.